So then it does pick out like all the sounds. So like if you're gonna be like super loud, it won't. I don't have like a mic yet, so it connects my voice to like this computer.
You should ask, does Miss Sullivan have one for the kids that are like deaf?
I asked for a mic. They had them then in the school.
Yeah, where it goes like it transmits to the kids who have the
hearing issues.
Yeah.
Very clever. All right. So there's some. Someone's gonna give me one. All right. Here's what we're gonna do today. All right. We're gonna do the definite integral with absolute value. It's not bad, it's just long. So it's kind of like what you guys did yesterday, but this time we're going to be finding the area under an absolute value curve between that and the x-axis. Alright, so here's our first example. So what your picture will look like here, just kind of give you guys an idea. Here's my absolute value. What we're going to be looking at is how to find the area from, we're going from 0 to 2, so 0 to 2, but what we have to take into account in here, because you're dealing with an absolute value, it's not, it's kind of split up. See how you guys have a part from, this is like 1/2 to 0 and then 1/2 to 2, kind of like segmented. So that happens because we're dealing with an absolute value. We have to take into account both parts. So the important part when we deal with absolute value is making sure we have both the sides kind of situated. So when we want to take into account both sides, this is what we're going to use. And you guys remember this yesterday, I know when you were talking about, you knew that there was like 2 parts. So the first one is we're going to negate the absolute value when we have x is less than, I'll explain this little part, where f of x equals 0. Now the other part of this is the absolute value of x, where x is greater than or equal to wherever f of x equals 0. Okay.
The top one is going to be equal to?
No, not equal to. Just like no line underneath. What I mean by this, because this looks a little funky, like, okay, what are we even talking about with this f of x equals 0? What you're going to put in this blue spot is when you go up to your original, we're going to have to figure out this right here is your f of x. If I just take that f of x, 2x minus 1, and I set it equal to 0, what would we get for x? Good, 1/2, right? So yeah, 1 divided by 2. Yeah, so x equals 1/2. So here, this 1/2 is going to be what would make our f of x equal to 0. So that's going to be what you're going to set on the other side of your inequality with dx. Right? So I just thought the notation is kind of funny in the book when you like look at that. That's all they're talking about is what would make your function equal to 0. Okay. So when we start this off, okay, well now that we figured out that this will make f of x equal to 0, when we do our 2 cases, okay, so we're going to do like case 1. We're going to use this right here for the first part. So we're going to negate whatever the absolute value of x is. So we're going to negate this whole thing. So negative 2x. I'm going to go in a lot of steps so you guys can really tell. Alright, so we're going to negate what's in the absolute value, and then this is going to be for when x is going to be less than. Oh, still positive? Oh, 2x minus 1, sorry, thanks. Sorry, there we go. That's right, 2x minus 1, good, okay. So when you guys bring this through, it's going to become negative 2x plus 1. Is that okay so far? All right, so what we're going to do in your case 1, this is going to kind of take into account when x is less than 1/2. So what that's going to show is this piece right here. right? This is like your 1/2. So we're gonna do this part from 0 to 1/2, because x is less than 1/2. So when we do our integration now, right, we're gonna go from 0 to 1/2. It's always the smaller part to the 1/2. And we're gonna have to do it in like 2 sections. So once you guys get to this part, it's the same thing we've been doing. I should add the x on here. So we're going to integrate it and then sub in. So if we integrate -2x, it's going to be squared over 2. What do you have to put onto the 1? X. Good job. So just x. Awesome. And then make sure we're careful with our, to simplify a little bit. So it becomes negative, then x squared plus x. We're going to go from 1/2 to 0. Okay. So let's figure out what the area of this would be. So we're going to start with 1/2. Put it in.
Plus c.
We don't have to, yesterday we didn't, no plus c because you're just evaluating over like a specified like spot. It's not going on for like ever where we don't know what it could be. No deal. Okay, so I'm going to put my 1/2 in. Okay. Alright, make sure we do this part first, and then we're going to minus when we put the 0 in. If I make a mistake, don't be afraid to tell me so. It's fine. This is literally for you guys. I don't care if anybody else sees this stuff. So, don't be like nervous. Alright, so let's see. This is going to give us. This is going to be, so we have -1/4, right, plus 1/2. Okay, what did you guys get there? 1/4, good job. Okay, and then if we're minusing over here, we're going to get a 0, so it's just 1/4.
And then you have to do the second case.
Yep, now we do the second case. Okay, so what this shows you guys, the area of just, all the way up here, just this little piece is 1/4.
But you have to be on side and back though.
Yes, exactly. Yep, you got it, Carolyn. So now when we do our case 2, the case 2 is going to take into account this chunk. So that's going to be like our case 2. We're going to do the same thing. Okay. We're going to follow though. This time, are you negating anything? No, it's just going to be what we had originally. Okay, so we just have our 2x minus 1.
Are we supposed to like write it any specific way?
No. I just like break it up into 1 and 2, just so you remember you're doing it 2 times, but it's not like you don't really have to. If you like to do it all at one time, I don't know, whatever's easier for you. Okay, so it was 2x minus 1, right? Thanks. And then this is going to be where x is going to be greater than or equal to 1/2. Right. So when we do our 2x minus 1, we want to evaluate this one now from 1/2 over. So this time though, what number should go on top if our original was from 0 to 2? Think about the 2, the bigger one. Because now we're going from 1/2 to 2, so the 2 is the bigger one, so that's going to go on top. And so it's going to be from 2, and then the 1/2 is going to be down here. So we're going to integrate first, and then plug everything in. So 2x squared, I wish you got my dx. Okay, make sure we're going from 2 to 1/2. And let's see what you guys get. Go ahead and plug that thing in. Make sure you guys really do each of them like individually before we subtract. This is negative 0.5. Alright, and then okay. So this is like 2.25. Did anybody else get that? No, that's supposed to be good.
Or
right.
5 halves.
Yeah, 5 halves. Yeah, 5 halves works. Yep. Now the last part, so this is the area of the right part.
9/4 area. Well, that's 9. Okay, that's 9/4.
Oh,
Total area.
2.594. Oh, sorry.
I thought that was the final answer, like in the actual, because that.
Oh. Yeah, well, we're gonna have to add both. This, I just did the right side. So, like, okay, so now we have, this is 1/4. We got, this one was 9/4. Okay, so when you guys add these together, so remember, you want the area of the entire thing now. So you would add them together to get the area of both of them. So 1/4 plus 9/4 is going to be 10/4. Yep. Oh my goodness. All right, so 1/4 plus 9/4, which is about, yep, 5/2, or if you want to do decimal, is it 2.5? Now, what's cool about this is yesterday I showed you guys a way to check this right on calculators. It's pretty accurate. I think it was like a 0.01 off, but you can still do this. Ryan, you have a calculator? Good. Okay, so if you guys wanted to check this, at least make sure you're right, because it's just long, right? Go to your y equals key again, right? Type in your absolute values, so go to your math, num, ABS. Right? We're going to type in our 2x minus 1. Right, we're going to graph this thing. Right, you can do this with all the supplements, right? Right. So what we're going to do is second calculate, and we're going to go down to choice 7, because this is our integration. And make sure you're going from 0 is your lower limit, 2 is your upper limit. Okay. Oh, it did it exactly this time. Look at that. See how it shows it to you? So you do 0. You want to do like your original. The calculator can take it. I know, right? Isn't that cool? 2.5? Woohoo! I'm glad someone else is using it, Carolyn. Right, did you get that one?
No, you enter 5, 0
That's
to 2.
because, yeah, I'm scared
So
you're
it said lower limit, and then you put
No, I
0.
said it's I didn't realize that I heard reading, I heard like it's crumbled before.
Yeah.
It's just telling you where you want to like calculate from. Okay, let's try another one. Hi, how are you? Oh, good. We're doing definite integrals with absolute value. How fun, you know. All right, so here's your second one. Do you have any good tips? Let me know. Okay. All right. So here's the next one, a little bit more complicated here. Definitely because we have like the minus sign. So the first thing we want to do is figure out where's your f of x going to be 0? Where's the absolute going to be 0? 3, good, okay. So when you guys set up your two cases, right, we have the negation of your absolute value is going to be x, where x is less than 3. And the second part, x, where x is greater than or equal to 3. Do you guys know how we got 3? Just the absolute value, yeah. No, so you're just taking what will make the inside of that 0. So if you want to take x minus 3 equals 0, yep. All right. So when we start this, be really careful of your negation, right? For your first case here, okay, we're going to negate the absolute value part. So we have 3 minus. Now if we negate inside here, think about it like this. What's going to happen with this? What's our information? Yep, so you're going to cancel out. You want to make it easier for yourself. What could you make that go? Just positive, right? So you're getting 3 plus x minus 3. And Carolyn, you said the 3 cancel, right? So right now we just have x. So when we integrate this, okay, we're going x is less than 3. So what's your interval going to be? Close, not here anymore though. Look at your original. 3 to what? What's your lower one? 1. 1, good. Yeah, we're going to go 3 to 1. Okay. If you need a picture, we want to graph this so you guys kind of get an idea. And I think it looks something like this. Alright. And here's like your 1, somewhere like this, and then 4. Okay. So, I know it's a rough sketch, you can use a calculator. Right. Why don't you guys try this part? See if you can come up with the left part of this. Do you know how to do it from here? Need more help? This is really fine. No, don't be weird because she's here. You guys need more help?
I don't think you invited us.
I know you're all so quiet.
I don't think so.
Yep. Yeah, good. So just do your integration, make sure you're subbing in 3, sub in the 1, subtract them. And you know what you guys get for your Okay, I'm just gonna write this in so Kaylee can kind of show this stuff. Hi, Kaylee. You know, she'll be happy later. So you'll get 4. I saw 4 and a lot of people. Oh. Good. So this is like your left part. So we know one of them's 4. Now we have to go through and do the other case. We have to do it when it's positive. Okay. So when we are just keeping everything the same, are we going to change any of this stuff? Well, yeah, that's fine. You're right. We do have to bring the negative here, but we're not going to like do extra negating. So for our case 2.
Yeah.
So when you guys are doing this part, bring it through, as you were saying. So we're going to get 3 minus x plus 3. So it should be 6 minus x. Good so far? The distribution? Alright. Now just make sure when we go to integrate this, where's your lower and upper limits? Like where, I shouldn't say this. Where are your integrals going to be? Good job. Oh wait, what am I doing? Which one's going to be on the top though? 4, because the bigger one.
I have a question.
Yeah.
Could you go up a little bit?
Yeah.
Actually just all the way to the top. Why did we start with 4 and then put in 3 for x?
Because 3 will make it equal to 0.
Wait, sorry, hang on. So why did you start with 4?
You see how I know it's you to integrate 4 and then 1?
Right here?
Yeah.
Okay.
And then below it,
We did 3.
yeah.
Because when you do your 2 cases, think about this is kind of where you're splitting. Like in the last one we did, it went to, we see how we did 1/2? Because that's what would make this equal to 0. So we just forget about those completely. Kind of. You have to do it in sections. So you're doing like the lower bound, 0 to whatever would give you the 1/2, like where this would give you 0, which was 1/2. So you're doing it in 2 sections. You're going like 0 to 1/2. And then, so you see this was 0 to 1/2. So you're using one of them at a time. The second time, we're going from 1/2 to the 2. So you're using what will make your function equal to 0. And then you're going like using the lower.
Okay, I see it. So it connects. Okay.
So it kind of connects it to one, but you have to do them both to add up.
That makes sense.
Does that make sense now?
Yeah.
So like, yeah, this is the important part of it. You need to figure out what's going to make that 0. So then you have your like, think about like a connector.
Okay.
Like the connector part.
So then would it be 4 on top and then we're going to
Yes, exactly.
Okay.
Exactly. Good. Alright, so why don't you guys try your second one and see what you get. If anyone wants to put it up, feel free. You get a negative number. Oh no, that's it. Oh, overall. That's, you mean,
Yeah.
okay, yeah, that's it. You got 4, right? First one?
No.
Second one? Okay, got it. I literally hate myself. I'm not even gonna spell this. I put 6x squared. Yeah, and then like exactly, and then, yeah.
It's got the same prefixes.
Do they call you?
Oh, here's why, okay. Because we integrate them. Okay, so you do like square root of 2, right? Like, right, is after, that's why. Any weird stuff, what you got? For the, right. Oh, yeah, so what you look at? Come on, bring something. Oh, 5,000.
3 questions. Cool, they're coming now. Got it. Oh, wait, no. I'm talking to you. When I work, oh my God.
I had to walk it today. And
Until like every quarter or two. No, mirrors.
I would not really.
I have to like be able to see it, otherwise I can't recall.
So what do I do at the end? Add them?
Oh, yep, add. Think about this is the area of one part, this is the area of another part.
It's 13:02.
Guys, you did awesome, good job. Oh, somebody did
You will write the conflict, and will you write it for about the senior trip too? Yeah. Like, that's how you do it. Yeah. I really appreciate it.
No problem, I,
Just move about it, like, I was like, no idea.
here's the thing. Yeah, I won't be able to do it till like Tuesday.
Oh my God, yeah, this is on Friday.
Yeah.
Wait, she does when the senior trip is at. When's the senior trip? May 22nd?
Yeah.
Amen.
Okay.
Do we know that?